Hey everyone, and welcome to your C++ tutorial on polymorphism. So, as you can see, I have Visual Studio pulled up here and our Hello World program ready to go. I'm going to delete the Hello World instruction and begin with a definition of polymorphism. And so polymorphism is the ability of a programming language to present a single interface. It's going to be kind of a long definition here. Let's get some more space here. For several, well, we'll just say for different types and thus behaviors. So it's the ability for a programming language to give you a single interface that leads to different outcomes, right? So we can think of that as a single interface, different behaviors, right? So with this one interface, you can get different behaviors. This is very useful when your program needs to, add or remove behavior or respond in some way to user input or input from another program. So let's take a look at this stuff in action here. I'm going to start off by creating a new class, and we're going to call this class vehicle. And I'm going to create a few, just one public method here. And I'm going to assign this method as virtual. And we're going to call, this is going to return void, and we're going to call this print. So finish our class with the semicolon there. And what our print method is going to do, I've already imported standard library and everything. So we're just going to print out hello from vehicle. Awesome. So we have our class here called vehicle. We have a print method in vehicle, and we have our just basic print statement here from vehicle. I'm also going to create a sort of standalone function. This is going to be a void. This is going to be called print vehicle greeting. And this is going to take a vehicle object. We'll call it input v or the. And we're going to make sure that this is a pointer memory location. And inside of our print vehicle, we are going to access input vehicle, and we're going to access the print method on that. Okay, awesome. So in our main function here, let's create a new vehicle object, call it vehicle, set it equal to a vehicle object. And we're going to call print on it. I know some of this stuff might be our print vehicle greeting. And we are going to pass in our vehicle. Vehicle. I'm going to pass in our memory location here. Cool. So I know a few of these things, like this virtual keyword, might be a little bit different. Maybe you haven't seen the syntax. We're passing in a memory location here or a pointer. And in this, we're using, it's a vehicle. It's a pointer that points to a vehicle type. And in here, since it's a pointer, we have to use this arrow syntax to access the vehicle type's print method. Down here, what we've done is we've created a vehicle object of vehicle type, and we're passing it into our function up here using its memory location or a pointer to its memory location. So use the G++ compiler to compile this, and let's run our program. And what do we see? We see hello from vehicle, which is awesome. So we have our print method that's getting called in this, and it says hello from vehicle. Awesome. So What does that have to do with polymorphism? Well, the magic here lies in this virtual keyword. And so this is creating a virtual function here. And so a virtual function is a member function that is declared within a base class and that can be overridden in child classes or redefined in child classes. And the reason that we need to pass in a pointer here is that, remember, a pointer points to a space in memory. That space in memory is formatted to be a vehicle type. So what we're going to do is we're going to create a child class of this vehicle type. And the child class will still be a vehicle. So the space in memory is still going to be a vehicle, and it's still going to get a print method. But since we've assigned that method to be virtual, that method can change during runtime. So let's do that now. We're going to call this truck, and truck is going to inherit from vehicle. And we are going to create our public space here, and we are going to redefine print, and we are going to print out hello from a truck. Cool. So we'll need to finish our class with a semicolon there, and we should be good. So now we have our vehicle, and we're passing it in. It says print vehicle. Great. What I want to do now is I also want to create a truck. We're going to give it the very creative name of truck. We'll assign it to a new truck object. And we are going to call print vehicle again, print vehicle greeting. And we are going to pass in the reference of our truck. And so I will run this now. We're going to compile main, run our a.out. It says hello from vehicle, hello from truck. I should create, I always forget to do this, but I'm going to do an end line here. And you know, I'm just going to run, I'm going to recompile this. Oh, yes. My bad, my mistake. All right, so what I'm going to do is in our virtual methods, I'm going to add the end line. And I'm going to clear, and we will recompile here. And we see hello vehicle, hello from truck formatted a little bit more nicely. So what's happening here is that we're getting different behavior from this same function here, right? So we have our interface, which is our virtual method, and it's called print. And because of this virtual keyword, we can assign it different behaviors at runtime. And so you can see where this would be kind of powerful, right? We're basically allowing for the same code to basically run different behaviors, right? So just to recap how this is working, we declare our parent class here. And in our parent class, we have a virtual method that prints something out. And then we inherit from that base class, and we get a copy of that virtual method. And we redefine it here or override it to fit the use case of our new child class. Our method, though, only takes the base class, right? And so it only takes the base class because that works for the base class and our child class. We couldn't do this the other way. We couldn't have a truck, for example. We can't do it this way because now we have an error here because we're passing in a vehicle, right? So if I try to compile this, it shouldn't work. Yeah, we get an error, right? And that's because truck inherits from vehicle. So every truck is a vehicle, right? But not every vehicle is a truck. Every truck is a vehicle, but not every vehicle is a truck, right? So I'm going to clear this. And this can be expanded even further than this. We could create a new class called car, and it can inherit from a vehicle as well, because a car is also a vehicle, right? And I'm just going to copy this class body, paste it here, finish off with a semicolon. Inside of our car, we can say, greetings from a car, right? And if we create a car class, and we call this car, and we set it equal to a new car, we can pass in our car, and we'll get our car-specific behavior. If we run A out, and you can see we're getting different behavior here. So this is pretty cool, right? So we can keep inheriting from vehicle, and we can keep morphing that behavior, right? So every vehicle is getting a print method, but each vehicle is changing the print method to be different. And so, this is also dependent on the print vehicle greeting taking in a vehicle, because remember, it's taking in a pointer to a vehicle. And so we know that the vehicle class has a print method. At the time of compiling, we know every vehicle is going to have a print method, but we don't know which vehicle is going to get passed into our print vehicle greeting function. It could be anything. Luckily, a car will have enough space for a print method. A truck will have enough space for a print method because they're all vehicles. During the running of our program, we can, dynamically figure out which item we want to pass in, and it'll just work because that memory location is defined at runtime. Okay, so let's try looking at this in a different way. So we have our vehicle class here, and our truck class and our car class, which both inherit from a vehicle. We pass them into print vehicle greeting, and it prints out whatever version of that print method exists. Another way of looking at this, if we remove this here, we'll get rid of all of this. Let's create a vehicle pointer here. We can also create a normal vehicle object, assign it to vehicle. For a vehicle pointer, let's call this poly for polymorphism. We're going to take our pointer here, and we're going to assign it to the memory address of our VEH variable, and we're going to print out our greeting from the vehicle. So I'm going to clear this, and let's use our G++ compiler to compile it. Let's run it, and we can see hello from vehicle. So what we're doing here is we're creating a pointer. We're creating a normal object right here. We're assigning the pointer to the memory location of the normal object, and we're accessing the print method of that object. So now what happens when we switch this type from being a vehicle to a truck? What happens now when we compile it? Yeah, you see, we get the hello from truck. We get different behavior. And so what's happening is that we create a pointer here at runtime that can point to any type of vehicle. We decide, hey, point this to a truck type, right? And we can access the print method on that truck type. So this is a different way of illustrating what that function was doing. And you can switch this to a car or anything else that happens to inherit from a vehicle. Now, what you cannot do is you cannot create a vehicle, a normal vehicle object, and assign it to the instance of a truck type. If we try to compile that and run it, oops, sorry, let's do poly.print. Sorry, if we compile and run this now, you're going to see we get hello from vehicle, even though we're assigning it to a truck type. That's because the print method invocation is, since it's not a pointer to a memory location, this is all determined at compile time versus runtime, which is when our previous examples were determined because they were pointers. So when you do this, just know that you're not going to get that good virtual function polymorphism. So that's been kind of a rundown of polymorphism, very introduction level rundown of polymorphism in C++. It's this type of sort of pointer use, and polymorphism is a big asset when you're going into the more complex design patterns, which you may learn about later in your programming career. But for now, this has been your introduction to C++ polymorphism. Thanks.